Hello everyone, I am Geraldine Molina from BSCD Math 1B, and I will report constructing perpendicular to a line. In this lesson, we are going to discuss constructing perpendicular to a line using a compass and ruler. Next, constructing perpendicular to a line using a putty paper. And last but not the least, the altitudes of a triangle. Before we start, what is perpendicular lines? Perpendicular lines are two intersecting lines where each angle formed measures 90 degrees. Let's proceed. Investigation number 1, finding the right line. Draw a line and a point P without on the line. From the point P, draw an arc or circle intersecting the line using a compass. Label them point A and B. Find the perpendicular bisector of line AB. What is perpendicular bisector? Each segment has only one midpoint. A segment bisector is a line, ray, or segment that passes through the midpoint of segment. A segment has many perpendiculars and many bisectors, but in a plane, each segment has only one bisector that is also perpendicular to the segment. This line is its perpendicular bisector. Find the perpendicular bisector of line AB. Let's use a ruler. 14 divided by 2 is equal to 7. Therefore, 7 is the midpoint of the line AB. Label it point M. That's the perpendicular bisector of line AB. Draw a segment PA and PB. Put a point Q on the line and draw a segment PQ. What do you observe in this figure? Let us put different kind of colors in each line segment. Blue for segment PB, pink for segment PA, orange for segment PQ, and green for segment PM. How is PA related to PB? I give you a hint. What is converse of perpendicular bisector conjecture? If a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. What is the color of the shortest distance? As you can clearly see, the shortest segment is the color green, which is the perpendicular bisector segment PM. You are ready to state your observation by completing the conjecture, shortest distance conjecture. The shortest distance from a point to a line is measured along the perpendicular segment from the point to the line. Here's another method on finding the right line only using a compass and a straight edge. Let's watch the video.
So this video is on constructing a line perpendicular to an already given line that's passing through a point P that is not on my line. So we're going to use our straight edge and compass to complete this geometric construction. The first step that you want to go through is using your compass tool. You're going to place the point of your compass on point P, and you're going to sweep an arc using your compass that will intersect the given line twice. Right now, if I sweep an arc, I'm not going to intersect at all. So I want to expand my compass to a point where I would sweep this arc, it would intersect twice. It's helpful when the points are pretty far from each other, so I'm going to stretch it a little bit further, and I have 1 and 2 intersections here, so here's my sweeping arc. It's going to intersect twice. So after step 1 here, we're then going to place the compass point where the arc crossed the line on one side. So I'm looking at one intersection of the arc and line, and I'm going to place my point of my compass there. I'm going to then go ahead and, if point P is right here, I'm going to draw an arc that is below. I'm going to draw an arc that is below point P on this side of the line. I'm going to draw an arc down here. And I'm going to do that to both sides. So the first step is going to draw this arc. Just make sure that's big enough and make a nice and big sweep there. And then I'm going to move the point without changing the span. It's very important, without changing the span of my compass. I'm going to move the point to the other intersection right here. And I'm going to go ahead and do the exact same thing, making sure that the two new arcs that I created, they intersect with each other. Now, with your straight edge, you should be able to draw a line from point P passing through the intersection of the two small arcs that we just created. So I'm going to take my straight edge here, and I might want to put one end right here and then rotate it. Rotate it up to the other point. So it's going to take a little bit of moving around, but once I get it situated, I should be good to go. And it's not going to be perfect, that's okay. So here I'm going to go ahead and sketch my line. Let's do that again one more time just to make sure we get it straight. So now that I drew my line passing through the points of the intersection, as well as through point P, we can now state that this given line is now perpendicular to this line is perpendicular to the given line passing through point P, which means they form a right angle at where they cross. So these two lines are now perpendicular to each other.
Let's have an exercise. Listen carefully. Draw an acute triangle. Label it ABC. Construct altitude segment CD with a point D on segment AB. We didn't forget about a point D. It's at the foot of the perpendicular. Our job is to locate it. Here it comes. All altitudes of the acute triangle are inside the triangle. What about the obtuse triangle? Draw an obtuse triangle OBT with obtuse angle O. Construct altitude segment BU. In an obtuse triangle, an altitude can fall outside the triangle. To construct an altitude from point B of your triangle, extend side segment OT. Here it goes. In an obtuse triangle, how many altitudes fall outside the triangle and how many fall inside the triangle? As you can see, 2 altitudes are fall outside the triangle and only 1 fall inside. That is the difference between acute and obtuse triangle. What about the right triangle? We can learn that later on at the end of this lesson, so let us continue to our discussion. Let's have another investigation. Investigation number 2. Patty paper perpendicular. First, draw and label line AB and a point P not on line AB. Second, fold the line onto itself and slide the layers of the paper so that point P appears to be on the crease. Label the point of intersection M. Are angle MMP and angle BMP congruent? Supplementary? Is M the midpoint of line AB? Point M, as you can clearly see, point M is not the midpoint of line AB. Angle AMP and angle BMP are supplementary because of the line AB. Line AB is straight line, which is measured 180 degrees. As we know, 2 angles are supplementary when they add up to 180 degrees. Are angle AMP and angle BMP congruent? Let us proceed to know the answer. Let us cut the 2 angles apart, then put angle AMP on top of angle BMP. As we can see, they are congruent. Yes, they are congruent. For more accurate, this is the measurement of the 2 angles. Angle AMP is 90 degrees, angle BMP is 90 degrees. It means angle AMP is equal to angle BMP. It is not a matter whether point M is the midpoint of line AB. It is alright as long as point M is the perpendicular bisector of line AB. Now, this is the last part of our topic. It's about the altitudes of a triangle. Altitude. An altitude of a triangle is a perpendicular segment from a vertex to the opposite side or to a line containing the opposite side. The altitude of a triangle is the height of it. A triangle has 3 different altitudes, so it has 3 different heights. Altitude 1 is the altitude 2 and the altitude 3. An altitude can be inside the triangle. An altitude can be outside the triangle. As you remember our question in the first part of our lesson, we asked earlier, in right triangle, where can the altitudes of it will fall? Let's see. An altitude can be one of the sides of a triangle. In right triangle, 2 altitude of it is the sides of the triangle, and only one is fell inside the triangle. The distance from a point to a line is the length of the perpendicular segment from the point to a line. Thank you! Bye-bye!